What's up, everybody? Alright, so I'm going to show you some code written in Python. I'm using Python 3.6. Been studying blockchain technology lately. Today I just been messing around a little bit with the SHA-256 algorithm. I'm using it in the hashlib library in Python. You see the import statement up top. Import hashlib on line 1. So let me pull this down a little bit so you can see the code. Just simple 30 lines or so. So you see my main function right here. So inside here, what I do is I'm using a while loop, and I'm calling query continue, which is going to return a bool. You see up here in the definition for the function query continue at line 3. What I'm doing is I'm getting some input from the user, asking them if they want to perform a hash. It's gonna assign that to user response, and then I'm gonna use an if statement to see if it's yes or no, and respond with a bool. If it's yes, I'm gonna respond with true. So it's gonna return true, and then we're gonna enter the while loop. So it's just a shortcut way of I could have did something like this up inside main. I could have said active equals bool, throw it a 1 for true, and then I could have said while active is equal to, while active is equal to true. Do all that instead of doing that and then setting it somewhere in here so that we can exit this while loop. I just folded all that into a function called the function on the same line as the while. So once we determine whether or not we're actually going to be performing a hash, then if it's true, we're going to enter the while loop. The first thing we're going to do is we're going to get the file name that the user wants to use for persistence. After we have that, we're going to store it in user file variable. You can see up here the definition for query file name. Where's it at? Right here. Okay, line 14. It's just getting some input from the user and returning it straight back out of the function. Again, I just compacted all that on one line. I could have did something like this. I could have said user response is equal to input, enter file name. Could do something like that. And then the next line I could have said return user response, like that. You can see instead of having 2 lines, I just used 1, down and dirty real quick, making the code compact. Okay, so after we get the user file, we're going to get the object or the string piece of data that we're going to run through the SHA-256 hash algorithm. We're going to get that from the user. So I say hash object equals hash string. This is my function to hash the string. So we come up here on line 17, the definition for the hash string function. Again, everything's compacted onto one line. It's real compact. It says return hash lib. Now I'm referencing that hashing library that's up here that I'm bringing in with the import statement on line 1. And so inside that hash lib library, there's a function called SHA-256. So I access that with the function, or the dot operator, though. method access operator. I don't know what it's called in Python. I'm used to programming in C++ and C#.net. So I call that SHA-256 function, and I get some input from the user. I tell them to enter a string to hash, which is, for all you non-programmers out there, that's just a string of characters, like your name. My name's Eric, so it would be ERIC. That's a string. So we get the string from the user, and before we pass that back into the SHA-256 function, we specify that its coding is encoded in UTF-8. So after we do that, it runs it through the SHA-256 algorithm, and it returns it to the where I called it. So we're storing that in hash object. Let me just show you what this would have looked like had it been broken apart onto multiple lines. So let's see. I could have said user string equals input enter string to hash. Then I could have said user string equals user string dot encode UTF-8, and I could have said hash object equals hash lib dot SHA-256, and then pass that the user string. Let's see. Then I could have said return hash object, like that. So 1, 2, 3, 4 lines instead of having 4 lines. I just got 1 line. Just notice something down here too, using the hex digest function. Instead of putting that there, yeah, can you put that there? Let's see if this runs real quick. Let me go up in my file. It's storing this. These are all previous hashes that I generated and just kept appending them into the file. So we're going to clean that out real quick. And then bring this back up real quick and run this. Okay, so you see the first thing it asks us is perform hash, and you'll see that at line 21 of my program, where I call that function query continue, that's defined at line 3. That's where you see the perform hash, yes or no. So that's where we're at right now. We're inside that function. So I'm gonna go ahead and type yes, enter file name. Now you could enter any file that you want here, and it's gonna create it if it doesn't already exist. If it already exists, it's going to open it. Right here, since I'm not really concerned with the format, I'm just reading Unicode characters, I believe, in and out of the file. I don't have to specify like .txt or whatever the file format would be. It doesn't matter. So specify the name and then enter the string to hash. So right here we're inside the function hash string. You can see enter string to hash. That's at line 18. So that's where we're at right there. I'm going to go ahead and just say hello SHA-256 exclamation. Boom. So you can see it hashed that string. Matter of fact, let me see. Okay, I'm not concerned with that right now. Okay, so you can see it says perform hash, yes or no. And that is because that method right here, or that function right here on line 21, query continue. So it already ran through this whole thing. It opened the file. So let me back up for a second here on line 23, where it gets the hash object. So we entered the string. It hashed it. It returned it from that function and stored it in hash object. So after that, it tries to open that data file that we specified when it says under the query file name function, line 14 and 15, where it says enter file name. So that's where that was stored. That was stored in data file. Actually, that was stored in user file. And so we create a file handle with that name of that file. We try to open it. If it can open it, it sets the mode to append. That's what the A stands for, and then it sets the encoding to UTF-8, and it returns the file handle and stores the reference of it in data file. And then in the next line, we use that file handle to write the hash object with a new line character after it. Let's see, and then after that, because we see it on the screen down here in the terminal, how did this get printed to the terminal? I thought we were writing it to the file. Okay, so it did write it to the file, but then the next line, we create another file handle, and this one we're setting the mode to read. So we have to specify which mode that we're going to be using, either read, write, append. And so same thing, we set the mode, the encoding, pass back the file handle reference, and then after that we print to the terminal, to standard out, we print the data file. And so we use that file handle reference with the read function, which is going to read to the end of that file, and it's going to pipe that output to the print function, which is going to write it to the terminal, standard out. Finally, it's going to close the file. Okay, so now, let me see, perform another hash. We've only done this once so far. You remember at the beginning I deleted all the hashes that were appended end to end in the file that I was using. So I'm going to say yes, enter file name. I'm going to specify the same file name. And then we're just going to some random string. Boom, and it hashes that, and it appends it to the file. You can see now we have two hashes in the file. Perform another hash? No. Okay, it says thank you for using string hasher. So that's just a real quick, down and dirty, quick little example of the SHA-256 algorithm. You can see this is a good exercise for anybody that's interested in blockchain technology, to just understand how hashing algorithms, hashing functions work. You pass something in, and in this case we're using SHA-256, so it's going to pass us back. It's going to spit out a 256-bit string of characters that appear random. Now, if we change just one number, one letter, one character in that string, it's going to give us a radically different hash as output. It's a one-way function. you can't run this hash back through that function and arrive at what we put into it to generate it to begin with. Also, it's deterministic. If you put the same thing in, although it appears random when it comes out, if you put the same exact thing in the SHA-256 function or algorithm, it's going to spit out the same exact 256-bit hash. Okay, now, if I go here, you remember we typed in new file, enter the file name, new file. You see that right here in my list of files in my directory structure right here. Go ahead and open that up, and you can see that's the same exact 2 hashes that's displayed right here. So that's all that's doing is it's just stacking these up. So let me open up Blockchain Explorer real quick. Let me see where that's at. Blockchain Explorer. Bitcoin Block Explorer. You may see something similar here. That's kind of what I'm going for. Now, when I refactor this code or rewrite it, like version 2, I'm gonna program it so that you can select a file that you want to hash. Actually, I'm going to give the user a choice. They can say, like, would you like to hash the text that you input into the terminal here, or would you like to hash a file? If you would like to hash text, enter 1. If you would like to hash a file, enter 2. If they enter 2, it'll ask them the path for the file. Now, this is all taking place in the terminal, so it can get a little tedious if somebody doesn't know the exact path of the file that they want to hash. So maybe in the future I'll use like a GUI or something like that, and I'll allow somebody to view the directory structure on the computer and actually like click and select the file that way. This is taking a while to display this block. Just show you. Matter of fact, you might not even be able to see that right now. Yeah, you're still looking at that screen. All right, my bad. Okay, so this is still trying to load. Do not know why. Okay, wait, there was some right there. Okay, so right there. Okay, look at it, it's just it's spitting them out. Apparently those are real-time transactions. But you can see those are all 256-bit hashes. Let's see if I can click on one of them. Yeah, so right there. I think you can copy it. Well, you definitely can copy it, but yeah. So those are how the transactions are stored in the block. Let me go back to PyCharm real quick. Let me get rid of this so you can see PyCharm. Okay, so I just copied that from PyCharm. I'm gonna drop it in here. See how long it is? Now that's in hexadecimal format, so, but that is 256 bits. And you can see that's the same length as the other ones. So go ahead and get that out of there. We'll go back to the Python code real quick. If you remember, I added this, I moved this hex digest function. It was down below. Remember when I grabbed that from, where did I grab it from? I grabbed that from line 27. It was right here at the end of hash object. So I moved it up there, but that's what that does. The SHA-256 is obviously operating on the binary representation of the string. To get it to that hexadecimal format, we'll use hex digest so that it's more human readable. Alright, so yeah, Python, SHA-256, blockchain, get your feet wet.